We've been talking about the periodic table. Mancham, stay with me here. Don't be working on the homework. Don't fall behind trying to get caught up. That's silly in my opinion. We have been looking at this notion of how atoms are made, and I'm going to be throwing a lot of key information at you over the next few days. Some really, really quick review. We talked about what was on your periodic table. Element number, I got a periodic table here. Everybody find element number 32, please. Okay. Germanium. Discovered in what country do you think? Okay, Germany. That's why it has that name. What's its element number? I'm going to ask you the same question. I want the same answer. I'm just going to phrase it differently, but I want the same answer. How many protons does it have? 32. How many electrons does it have normally? 32. Okay, those are all the same answer. Then, what's its atomic mass?
69.
No, read carefully. 72.6, yes? Okay, you have your pink periodic table in front of you as well, yes?
Yeah.
Well, then look at it instead of looking at someone else's. By the way, the reason I'm also doing this is you're going to find, Manchan, believe it or not, your eyes and your brain will actually start to memorize where to look. You'll think something, and without even realizing it, your eye will glance to that area of the periodic table. Even though you didn't think you had memorized where something was, your brain will actually store that subconsciously. So I'm going to keep referring to it. What was the atomic mass of germanium? Round that off to the nearest whole number. That's going to be 73. How many? What was its atomic number? How many protons? How many electrons? 32. If you go 73 minus 32, that's how many neutrons it has. Do the math in your head. Or I said you can start bringing a calculator. 41. It's got 41 neutrons, 32 protons, 32 electrons, atomic number 32. All of that and more is contained in your periodic table. There's more stuff that we can also deduce from this. We'll be talking about that over the next few days. But just that alone, you absolutely better believe that I will be asking you to tell me how many neutrons or how many electrons or how many protons certain elements will have. I'll either identify the elements by name. If I use an element by name, it'll be a fairly common one. I'm not going to try and make you go hunting for an obscure one. Or I'll identify it by atomic number. Then I can do an obscure one because they go in order. Okay? So, we also noticed that the atomic mass almost always increased as you move down. There was one weird exception. And I also did say the bottom quarter of the periodic table, that's where radioactive stuff happens, and almost all the rules that I'm teaching you don't work anymore there. We're going to kind of avoid that area a great deal. Here be dragons, as we say. We want to talk about ion charge. I'm going to start to explain to you the number in the top right that often has a plus sign or a minus sign next to it, and what that means. So atoms can gain or lose electrons. I'm not going to write the word electrons. I'm going to use my handy-dandy schmandy abbreviation. And when they do that, they become charged. Normally, atoms are neutral because they have the same number of protons and electrons. So let's look at germanium. If you have 32 pluses, protons, and if you have 32 minuses, electrons, what's positive 32 plus negative 32? 0, neutral. But atoms can lose electrons. They can, we later learned, do something with the protons, but we're going to pretend for now, Jordana, that the protons are locked inside the nucleus in the center of the atom, and so we can't do much with them. When we discovered radioactivity, that's what explained what was going on there. Weird stuff was happening in the nuclei, but we're not going to worry about that right now. Okay? So, atoms can lose or gain electrons. When they do, they become charged, and we have a fancy name for that. We call them ions. An ion is a charged atom. An atom walks into a bar and says to the bartender, "I've lost an electron." The bartender says, "Are you sure?" The atom says, "Yes, I'm positive." I told you that joke, but here's the next punchline. The bartender says, "Oh, I'll keep my eye on you." Okay, that's the full joke. That's how it all goes. Okay? If you gain electrons, what's the charge on an electron? Negative or positive? So if you gain electrons, you become more negative. If you lose electrons, if you lose negatives, what are you really becoming? Are you positive? Okay. If you lose electrons, you become positive. This is kind of tricky because it would be nice if gaining meant positive and losing meant negative. It's not, because electrons are negative. So you always, Jimmy, whenever you answer a question like this, stop, think it through really carefully. I always say in my brain, losing electrons, I'm losing negatives. Losing negatives means more positive. Or gaining electrons, gaining negatives means more negative. There's a pattern. Look at the metals, which is on the left-hand side of your periodic table, and look at the numbers in the top right. So let's look at magnesium. Find magnesium. Element number what? 12? What's the number in the top right? 2 plus. Find another metal. How about chromium? 2 different numbers, but both of them are plus. Yes? Let's find another metal. How about potassium? Okay. You're going to find metals. One of the reasons that metals are metals, one of the reasons we classify them the way they are, they want to lose electrons. They want to become more positive. It's also why they conduct electricity so well. Electricity, the root word is electrons. Metals conduct electricity because they're happy to pass electrons from one atom to the next atom, to the next atom, to the next atom. And if we put them in a wire, that's current, that's electricity. Look at the nonmetals. Find, fluorine. Negative. Let's find another nonmetal. How about selenium? Element number 34. Negative. Nonmetals are desperate to gain electrons, which is why they typically form a negative charge. They want extra electrons. Okay, so this is the pattern. It's on your periodic table, Jimmy. I showed you how you can figure it out, although it's probably worth committing it to memory, but you probably will just because we're using it so often. Nonmetals become positive. Sorry, metals become positive. I said nonmetals. Metals become positive. Nonmetals become negative. And in the middle, these weird metals near the middle, some of them form more than one type of ion. Those are the ones that have more than one number in the top right corner. Those ones are trickier. Some have 2. You can see manganese, element number 25, has 3. Actually, most of these, the numbers that are on your periodic table, are the most common ways they'll form an ion, but often there's more obscure ways that we just didn't bother putting on here. So far, so good. We're going to work on the worksheet later on. We're going to keep going. I screwed up. I forgot to include this in your notes. Next time, sharpen your pencil before. I think we've done this before, you and I. I forgot to include this in your notes. You're going to have to write this down. So at the bottom of the front page of your notes, you have a big white space, yes? Make a little heading and call it reactivity. So at the bottom of your front page, I think, are we on the back page or the front page yet? Yeah, so on the bottom of the front page. Oh, you can put it there too, but it fits in here. So it fits in kind of nicely on the front page. So write the word reactivity and underline it like a little heading. And then you don't need to write the brackets. But here is the rule. I'm going to read it out and then we're going to summarize it because there's no way we want to write all this out. So you can write rule and then put a little colon. Okay? The rule is this. If you want to know how reactive atoms are, the further down and out you move on the table, the more chemically reactive the element will be. We're not going to write that out. Too much writing. What are we going to write instead? I would write something like this. I would go, oh, that's a bad color. Hard for you to read. I would say rule, colon, more reactive as we move. What was the three-word phrase that I used there? Down and out. What I mean by that is elements in the middle here, they're reactive, but meh. Elements over here, holy smokes! And as you move further down, holy smokes! And as you move even further down, holy smokes! This column here is a special column we're going to spend a day talking about. These are completely non-reactive. These are called the inert gases. But one column in, the second last column, holy smokes! Okay. And by that I mean, hey, if you're using those, you're wearing eye protection, sometimes a hazmat suit, always gloves, and even then, depending on what element we're talking about, you're scared spitless here. This is stuff that if you do something wrong, you're going to melt your lungs. So, I think I showed you a couple of days ago a video. You saw that British professor with the big gray hair poofed out. So his lab assistant, you briefly saw him. He's this old, bald guy. He's been working with chemicals for years and years. And you'll see him in other videos because I have some other videos by him as well. He gets the goods for me. He has worked with and been exposed to, in a lab accident, fluorine, which is basically mustard gas. And he survived, but I think he still has scars from it. So, whew. Then we're going to write this. Don't write the word so, but you can write K is. Leave a blank. K is, leave a blank, then Li. Now I'm not going to say K. What's K on your periodic table? Okay. Potassium is, find potassium on your periodic table. What's Li? Lithium. See where it is? Is potassium more reactive or less reactive than lithium based on what I've given you with the down and out? So this is what you can write now in the blank. It's more reactive. I forgot the word reactive, didn't I? Okay. More reactive than lithium. We're going to repeat that with Mg and Na. So you ready? I'm going to teach you a shorter way to write this. Look up. Put the Mg right there. Put a ditto mark right there, a ditto mark right there, a ditto mark right there, and what was it, Na? I think it was Na. Have you seen ditto marks before? If you haven't, now you've seen them. That means you just drop the same word right down and it ends up right there. Find Mg. What's it called? Okay, magnesium. Find Na. Okay. Is magnesium more or less reactive than sodium? Less, because it's towards the middle, right? Down and out. Oh. Down and out is more reactive, so magnesium's towards the middle. It's going to be less reactive. Okay. We're going to do one more. We have S and Cl. So S, ditto mark, blank, ditto mark, Cl. And I think this all fits on the bottom of the front page there somewhere, yeah? So, what is S? Find it. Sulfur, element number what? Okay. By the way, if you right now are just sitting and not finding these yourself, you're missing out on the opportunity to start to train your eyes to look in the right locations. Because by the way, these elements that I'm picking are often ones I'll be using later on. So I'm already training your eyes just to spot where they are. Your brain will subconsciously remember, Paige. It'll happen. I've done this before. So S, sulfur, and then Cl. So which one is more reactive? Really what we're saying is chlorine outside or inside? Sulfur. Outside, so sulfur will be less reactive. Sulfur you can hold in your hand. Chlorine you would not want to hold in your hand. Chlorine you would also probably want to be wearing some type of a gas mask, or you would certainly not want to inhale it. Sulfur, meh. Okay. We got more. There will be some. I gotta get there though. I haven't taught you enough yet to make the videos educational. Now we're going to get some cool videos. Is it now turn the page or families, wherever you guys have families? The periodic table is arranged the way it is because we have put the atoms into families. Families are the vertical columns. They're all in the same family. And some of them, the names are on the sheet. What do we call the family in the first left-hand column right there? It has the name at the bottom. These are the alkali metals. They're cool. They blow up when you put them in water, sometimes spectacularly. Right next to them is what? Alkaline, with an N-E, earth metals. I wish they hadn't named them alkali and alkaline, because when you say them fast, it's hard to tell which one I said. You're always going to hear me say alkaline, and I'll emphasize the N like an idiot just to make sure you know what I'm saying. Another family we're going to look at is the second last column, halogens. You may have heard of halogen headlights. That's one of those is used in there. And another family we're going to look at is the very, very last family, the noble gases. Okay? So columns of elements in the periodic table that have similar properties are called families. And some have names that you need to know. So the first one, the left column on the periodic table, what do we call that? It's on your chart, so you don't need to memorize it. What's the leftmost column? Alkali metals. They are very reactive. They're very soft. You can cut them with a knife. Put your pencils down. Look up. David wants a video. Okay. The next column, we have the blank earth metals. This is the second column from the left. The what earth metals? What does it say at the bottom? Alkaline with an N. Alkaline earth metals. Second column from the left. These ones are pretty cool. They burn in air to give bright colors. In fact, they're used to make fireworks. How many of you have seen fireworks before? Okay. You may have noticed different colors. Yes? It's all basically the different alkaline metal they put in the firework. Put your pencils down. David wants a video. Pick your pencils up. The 17th column, the second last column. What's that one called? Halogens. And the halogens are very reactive. Very, 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 very reactive. What are the halogens? What's the first one? Fluorine. Next one. Chlorine. Next one. Bromine. Next one. In North America, for some reason, we pronounce it iodine, but it really, I think, is supposed to be pronounced iodine because it's continuing with the enes. I'll flip-flop back and forth. And the one right beneath, the bottom of it? Acetine. And then there's a placeholder that I think only got named this year. Anyways, what are the halogens? Put your pencil down. The last column. What's it called on your periodic table? Noble gases. Why are they called noble gases?
Why are they called noble gases?
Well, it was because for the longest time we thought they couldn't react, and so we had this idea of a king sitting on his throne, not being touched by anything, everybody being kept away. The noble gases, we thought for the longest time, didn't react at all. Actually, in the mid-70s, a prof at UBC was able to get, I think, xenon, the fifth one down, to react with something, which required a rewriting of the textbooks. So we're going to say, for all intents and purposes, Quinton, the noble gases don't react. But it turns out, with some really expensive multi-million-dollar equipment, you can kind of get them to sort of. David, you want a video? Put your pencils down, look up. A bit more. Things to notice. So the columns we call families. That's the vertical part. The rows we call periods. That's why it's called the periodic table. So notice that periods, or rows, go horizontally or across. That's probably a better word for you folks. Horizontally is a big word. Across the periodic table. You can put horizontally in there too if you want. But and families, yes, or groups, go up and down, vertically. So find bromine or bromine. Okay. What element number is it? Okay, everybody find it? What period is it in? Count down the number of rows. No, what period is it in? No. Look up. Ready? What period? Count with me. 1, 2, 3. What period is it in?
4.
I think it's in the 4th period. Is it 3? I'm looking upside down. No, it's 4th. Look, ready? Count with me. 1, 2, 3. 4th period. That's a terrible 4. Let's try that again. And row.
17.
That is labeled along the top, thankfully. 17. And what family is it called? Halogen. Helium, find it, I think right here, is in period, first period, row, and family, noble gas or noble gases. Okay. Next class, you want to bring some pencil crayons. We're doing a little coloring assignment. You probably want to start bringing a calculator. The homework I already snuck in. It was section 2.1 homework, which you've already done because I covered enough of it and you could handle it last day. A couple more videos to show you.